In this lesson, we are going to be talking about momentum. So by the end of the lesson, you should be able to calculate momentum, explain what conservation of momentum is, and you should be able to use the equation m1v1 equals m2v2 to show that conservation of momentum is true. So what is momentum? Well, it is the force something has when it's moving. And momentum depends on the mass of the object as well as the velocity it's traveling at. So if an object is at rest, that means it has no momentum. No matter how large of a mass it has, it's not moving, so it's not going to have a momentum because momentum is the force something has when it's moving. So if you're walking across your room, you have momentum. But if you're sitting on your bed, not moving, watching TV, you do not have momentum. Well, how do we calculate momentum? Well, momentum equals mass times velocity. So our equation is P equals m times v. P, this is your momentum. And then you know that m is mass and v is velocity. And our typical units for momentum are kilograms times meters per second. So whenever you're calculating momentum, whatever number you get, this is the units that you are going to have for that. So let's do some practice. What is the momentum of a soccer player that weighs 74 kilograms and is traveling at 8 kilometers per hour? Okay. So remember, our equation is P equals m times v. Well, we're looking for P. We know our mass, that's 74 kilograms. And we know our velocity, that's 8 kilometers per hour. So let's take 74 times 8 to get a momentum of 592 kilograms times kilometers per hour. All right. So let's try this one. What is the momentum of a 0.1 kilogram mosquito flying at 59 kilometers per hour? All right. Again, we know our momentum equation is P equals m times v. We are looking for our momentum. We know our mass is 0.1 kilograms. Our velocity is 59 kilometers per hour. So let's take our mass, which is 0.1, times our velocity, which is 59, and we should get a momentum of 5.9 kilograms times kilometers per hour. All right, so that seems easy enough, right? Well, now let's talk about conservation of momentum. So the conservation of momentum is saying that the total momentum of any group of objects remains the same unless an outside force acts on that object. So let's think about those balls where you lift one side up, let it go, and then it goes all the way through to the other one, and it keeps doing this back and forth, moving the very last ball each time it hits. And unless we do something to this mechanism, it's going to keep moving the last ball. So using the idea that unless an outside force is acted upon it, the momentum stays the same, we can use the equation m1v1 equals m2v2 to calculate different components of the items that are in that group. So using this equation, we could figure out the mass or the velocity of each of the end balls that are moving in this awesome little contraption. So let's do some practice. If a linebacker blindsides a 180-pound quarterback at a speed of 20 meters per second, the quarterback is accelerated to a velocity of 27 meters per second. So how much did the linebacker weigh? Well, remember our equation is m1v1 equals m2v2. So m1 stands for mass 1, velocity 1. Mass 2, velocity 2. So our m1v1 is going to be the mass and the velocity of the quarterback in this case. So we know our mass of the quarterback is 180 pounds. So we're going to write that. And then our velocity of the quarterback is 27 meters per second. So that's going to be on the left side of the equation. And then we know our velocity of our linebacker is 20 meters per second. And we're looking for his mass. All right, so to figure out his mass, we have to divide both sides by 20 meters per second. So now we have m2 equals 180 times 27 divided by 20. So if we do that math, take 180 times 27, divide that by 20, we figure out our linebacker weighs 243 pounds. And that is not surprising for a linebacker at all. Let's try another one. So if Joe Mauer is practicing hitting by hitting a ball off of a tree. So if Joe Mauer is practicing hitting by hitting a ball off a tee, his bat speed is an impressive 50 miles per hour while swinging a 1 kilogram bat. After making contact, the ball's initial speed is 344 miles per hour and the bat stops cold. So what's the mass of the ball? All right, so again, our equation is m1v1 equals m2v2. Our mass and velocity, 1 is going to be for our bat. So the mass of our bat is 1 kilogram. Our velocity for our bat is 50 miles per hour. And then we know our velocity of our ball is 344 miles per hour. Okay, and we are looking for the mass of the ball. So again, to get the mass by itself, we have to divide both sides by 344. So now our equation looks like this. 1 kilogram times 50 miles per hour divided by 344 miles per hour. So if we do the math on this, we take 1 times 50. Well, that's going to give you 50. Now divide that by 344. The mass of our ball is 0.15 kilograms. No wonder it went so fast. It has a very little mass. All right, so let's just do some recap on this short little lesson. Momentum is the force something has when it's moving. We use P equals m times v to calculate momentum. The conservation of momentum means that the total momentum in a group stays the same unless acted on by an outside force. And we use the equation m1v1 equals m2v2 to show that the conservation of momentum is true. So this ends the small lesson for momentum today. If you have any questions, again, always write them down in your journal unless you feel they're pretty urgent. Don't be afraid to email me or text me your question, and hope you have a great day.